Hello, welcome to Engineering Problems and Solution. And today we are going to look at the topic which is dimension analysis technique. And we have one question here, and we are trying to solve this question using our formula and then verifying that answer which we have got from the formula by using dimension analysis techniques. All right, so let's look at this example. So it is basically engineering example, as you can see here. The example says that lifting system use a transport engine parts, and the system consists of drum and cable. The following data has been provided. The following data, which is drum, has diameter of 0.4 meter, mass of the load is 4 kilogram, initial velocity of the load is 0 meter per second, time distance means the time taken for the load to reach on top is basically given as 4 second, and then length of the cable is given as 3.25 meter. Now to understand more nicely, let's draw this diagram here. So this is my drum, and then this drum is connected with a load with a cable. Okay, so this is my load here, and that's my cable here, and that's my drum here. Okay, so we have a diameter of a drum here, which we're gonna say as capital D. Mass we refer as M. Initial velocity we refer as U. And time distance we'll refer as capital T, or let's use that small t. So we're gonna use this as a small t, and then cable length we can represent that as a S, because it's considered as a distance travel. Right, so once we have all the information, let's see what we need to calculate here or determine. The things we need to calculate here or determine are 6 parameters. First one is final initial velocity of load, so we're gonna refer as V, and then linear acceleration of load, which we refer as acceleration, which is A. And then we need to find the final angular velocity of drum. As you can see, drum is in circular motion, so you're gonna have to calculate angular for any circular motion object. So we need to find angular velocity, which we can refer as omega. And similarly, number 4, we need to find angular acceleration, which we can refer as alpha for drum. And then we need to find the tension force in the cable, which we can refer as tension force as T. And then finally, we need to find a torque, which is experienced by drum, which I'm going to say as TQ. Right. Now let's see what is the criteria given to us. The criteria here, you can see here, it says use formula to solve the above parameters. So we need to apply formula. If you remember your physics class, we have particular formulas like S equals to ut plus half at square, and S equals to u plus v divided by 2 times t. So those formula we're going to apply to find out our parameters for the linear, and the similarly for angular velocity and acceleration as well. And then what we're going to do here is we're going to verify our calculated value by using dimension analysis techniques. And that's going to be more concern, where I'm going to show you how we can use the relationship of dimension analysis to verify or to check our answer, which we used, which we calculated using a formula. Right, so without doing any delay, let's start our solution. So first what we're going to do is we're going to write this solution here, and to make things easy, what I'm going to do is I'm going to go with this solution very slowly and step by step. So what I'm going to do here, on my left hand side, I'm going to solve these parameters one by one by using formula on left hand side. So I'm going to say here as we are trying to find final linear velocity. Okay, so we are finding final linear velocity, which is v, and my left hand side and this side I'm going to use formula. So formula to calculate final velocity, and then right hand side I'm going to use dimension analysis technique. Dimensional analysis. So we're going to use basically formula as well as dimension analysis at the same time to get the answer and verify it. Okay, so what we're going to do here, as what we need to find is we need to find the final velocity, and the simple formula we can use to find the velocity or final velocity is distance travel equals to u plus v divided by 2 times t. Okay, that's the formula we can use to find our final velocity. However, if you look this formula, we have to rearrange the formula so that we can find our velocity in one side and every other parameters on other side. So let's rearrange this. Now, rearranging, remember we need to focus on our final velocity, which is v. So what we're gonna do is we're gonna throw this 2 on that side, and we need to throw this t also on other side. So we're gonna get 2. We are gonna get 2s, and because it's a divide there, so it's gonna multiply on other side. And since time is multiplying on other side, which is right hand side, if you throw that into left hand side, it's gonna be divide. You're gonna get u plus v. So once you get this, we are gonna rearrange this. Remember our focus on our v, and then so our final, we don't want u on our right hand side. We need to subtract that u on both sides. We're gonna get v equals to 2s divided by t minus u. Right, once we get the desired formula, which we need to apply, then let's look at the question and find out what is given to us. So initial velocity, so what is given to us? Initial velocity is, let me write down here. So we have initial velocity as 0. We have displacement. We can say displacement is a cable or load traveling this distance, which is length of cable. So our displacement is gonna be 3.25 meter. If you look in the question here, 3.25 meter. And then we have, what I'm gonna do is I'm gonna use different color here so that you can see this more nicely. All right, so we have let's use u. We have u is given as 0 meter per second. Yes is given as 3.25 meter, and time is given as what, 4 seconds. And then we need to find the final velocity in this example. Right, so let's substitute all the given parameters in the above equation, and let's see what we're gonna get. So if we use this value, 2 times 3.25 divided by 4, as you know that u is 0, we are gonna get this value as 1.625 meter per second. That's the value is gonna be for our final linear velocity. Okay, now this we use from the formula. Now what about dimension analysis? Now dimension analysis, you have to remember what is basically a dimension analysis. Dimension analysis is a technique which is used for the physical quantities. So if you know your length, if you know your time, if you know your mass, then any quantity or any parameters can convert it in those fundamentals dimensions, for example length or mass or time. So what I mean to say here, that any relationship can be simplified into fundamental dimensions, which are time, which is t, which is mass, which is m, and then we have a length, which is L, and then we have temperature, which is going to be our small t, and then finally charge. So these are the, which we're going to say q. So these are the 5 fundamental dimensions. So any parameters can be converted in these 5 fundamental parameters, and then using those information we can calculate the value, or we can calculate the result. So every parameter should be converted into this fundamental dimension. So that's the key point. So what we're going to do is we're going to take that relationship which we have, which is yes equals to, let's use a different color here. So we're going to use that relationship for the velocity. So we're going to use s equals to u plus v divided by 2 times t. Okay, now what we're going to do is we are going to convert each parameters into its fundamental dimension. So yes is a distance. Distance is converted into length. So distance is basically length. So what is the fundamental of that is going to be length, which is L. And then we have basically we have t, which is time, and we're going to write that t. And we also have u and v. Since we need to calculate v, we are going to left this as it is, and we know that from the information that u is 0. So we're not going to write anything for the u, and we're going to find that. So rearranging this, we're going to get v equals to 2s t minus u, and we know that u is 0, and let's substitute that value there. So v equals to 2l over t, and you can see there that L over t is literally is meter per second. So you can see the units are nearly same, because the unit of length is meter and the unit of time is second. Now let's substitute the value. So same we have here, L, which is distance, is 3.25 meter, and time, which is given us as 4 seconds. We're gonna find v is what. So we are gonna use this and substitute the value. V equals to 2 times 3.25 divided by 4, and we got 1.625 meter per second, and that's our answer using dimension analysis. Right, now what we're gonna do is we're gonna go to the next question or next point to calculate, which is linear acceleration. So second one we're gonna find is linear acceleration of load. So same thing, first let's write what is known to us. Again, our displacement is 3.25 meter, initial velocity is 0, final velocity we already know from the formula, which is 1.625 meter per second now. And then we don't know the acceleration, that's what we're going to find, and time is known to us, which is 4 seconds. Now what we're going to do, same thing, we are going to use a formula here. formula, and then here we're going to use dimension analysis. Right, so formula for this one is we need to focus on acceleration. So we can't use the formula as which we use previous formula, which is s equals u plus v divided by 2 times t, because we don't have acceleration there. So we need to have a formula which contain acceleration. So for this, we have a formula which is s equals to ut plus half at square. And we have all the information needed to calculate our acceleration. However, we need to rearrange this relationship so that we can get our acceleration. Now, interesting thing is we don't have u, or we have u as 0. So this term is going to be 0. So our formula can be simple as half at square, because our u is 0. Now let's rearrange this. Now rearranging, you can see is half. So if you get rid of that half, you have to multiply both sides by 2. So you're going to get 2s equals to at square. Also, you are only focusing on a here, which is acceleration, and you need to get rid of that t square. So you need to divide both sides by t square, and you're going to get a equals to 2s divided by t square. Right, once we have this, we are going to substitute the value which is known to us, which is s, v, u, and t, and we're going to get the acceleration. So our acceleration will be 2 times 3.25 divided by 4 square, which we're going to get here is 0.40625 meter per second square. So that's the acceleration value which we are looking at. Now, what to do with the dimension? Same approach. However, we need to change our relationship on our fundamental dimensions. So we're going to use same relationship as we have a equals to 2s divided by t square. And here we're going to substitute what is s. S is our length, t is our time. And let's see what we're going to get for the acceleration. Acceleration equals to 2l divided by t square. And it makes sense as well, because unit, if you check the unit of acceleration, we're going to get meter per second square. So it's, yeah, it satisfies that unit. And let's substitute the value, and what we're going to get here is 2 times 3.25 divided by 4 square. Let's use like that, and then we're going to get acceleration as 0.40625 meter per second square, and that's the acceleration which we got from dimension analysis. Right, now we're going to go to the next one, which is final angular velocity. Now we are going to the angular side, which is towards the drum, and third one. So what we're going to find here is find angular velocity, and we of the load, no, of the drum, sorry, of the drum. And what we're going to do here is we are going to use the formula, same thing here, with formula and with dimension analysis. So right, so what we're going to do for the relationship of this, we need to have the information. So let's write the information, and we have t is for second. We need to find omega, Okay, that's what we need to find. We need a velocity, a linear velocity, which is 1.625 meter per second. And then we need a diameter of drum, because we are looking at the drum, which is 0.4 meter. So so diameter can give us a radius value, which is going to be r. Radius is basically half of diameter, which is going to be 0.2 meter. Yeah, so once we have all this information, we should be able to calculate our angular velocity. Now, angular velocity is basically given by the formula is omega is nothing but linear velocity divided by radius. Okay, and that's our relationship. So if we use this, we have 1.625 divided by radius is 0.2, and we are gonna get our answer at 0.8.125 radian per second, and that's the answer using formula. Now what about dimension? Now dimension for the angular gonna be a little bit tricky. Now for that, what you have to do, again, first what we have to do, we have to convert our relationship into the fundamental dimensions. So as we know, the relationship is this, which is omega is v over r, and we know v has a dimension of is 2l over t. If you go back to our dimension here for the here you can see that's the relationship we have here, right? So 2l divided by t for the v, and that's what I'm using here. And r is your length. The unit of r is basically meter, so it's a length. So we're gonna write this l. So what we're gonna get here if we use this information, right? If we use this information, we're gonna get omega as 2l divided by t, and then divide by l. Right, so we're gonna get this. If we write this a little bit nicely, you can see we're gonna get this omega equals 2l divided by t, because that t goes down, then you have l. That dot multiply, that means it's multiply. So you can see l and l can cancel out each other, and we're gonna get here as 2 divided by t. All right, so you can see dimension analysis giving you the unit as only unit. If you look the unit of this dimension analysis omega, which is angular velocity, you're gonna get that the unit is just per second, which is there isn't any radian, there is just per second. So there is an information, but it's not complete information. So let's calculate this first. So if we have 2 and then we have 4, we gonna get 0.5 per second. But if you look your answer of your formula, we are getting 8.125, and our answer for this omega is 0.5. So they are not matching with each other. And plus, if you look the unit, they are also not matching with each other. So there is something different, and the difference in the dimension is because of the angle. Normally, what happens in dimension, that angle, I would write this as a note with different color. Okay, note that dimension analysis angle, okay, is dimensionless. Dimensional, right? Dimensionless. Okay, and that's what's happening here. Now what we need to do is we need to calculate, to match our answer, we need to calculate angle and use that angle basically to use that angle, or we can find the distance, or yeah, angle, and use that angle that is a radian, and then multiply that, and so that we will get our omega in radian per second, because it's not a complete answer. So let's find the angle. So what I'm going to do is I'm going to use this side here. Let's find the angle. That angle should be on radian. Angle that must be in radian. Okay, and we have a formula for the to calculate the angle, which is theta, which is angle, is equals to r, s divided by r, which is s is basically your arc length, and r is your radius of the circle. So if you look that, we have s, which is arc length, is going to be 3.25, and then your radius is what, 0.2. So using this, we're going to get the angle, which is our radian value, is going to be 16.25 radian. So once we get this radian, we can multiply with this relationship. So what we're going to do is this value and this value, we're going to multiply with each other. And once we multiply them, we are going to get our final result of omega as 0.5 per second times 16.25 radian, going to give us omega as 8.125 radian per second. And hence we got the same answer, and hence we verified it. And that's the tricky part. You have to remember that your dimension analysis don't refer angle, because angle is referred as a dimensionless. It doesn't have any dimension, so it is totally ignored. So when you are gonna calculate the same answer, you need to implement the angle, and you need to calculate that angle and put such a way that you're gonna get the same answer. All right, we're gonna move to a different one. Number 4 now. Number 4, which is what we have to find now. To find the angular acceleration. Angular acceleration of drum. So again, we're going to use formula on this side, and we're going to use dimension analysis on this side. So the formula for the angular acceleration is given as alpha is angular acceleration. Remember that we are trying to find alpha, and you need to have the initial velocity, which is omega 1, plus omega 2, which is your final final angular velocity, which we have calculated, which is 8.125 divided by time. And that's our relationship, or that's our formula. So what we have here, since your angular linear velocity was 0 because it was resting, and the same thing was happening to drum, it was resting also. So the omega 1 is initial velocity, okay, which is 0. So we'll get alpha equals to omega 2 divided by t, and omega 2 is your final velocity, which we have calculated 8.125. So we're going to get alpha as 8.125 divided by 4, and we are going to get this answer as 2.03 radian per second square. And yeah, it makes sense as well because it's our acceleration, so we should get radian per second square, and that satisfy this answer. Now what about the dimension? Now for dimension, we can do exactly the same way, and we can use this relationship. So our relationship is alpha equals to omega 2 divided by t, and we can take our relationship of omega from the previous example. So omega is simply is 2l, no, is 2 divided by t, and t is simply t. So we're going to get alpha as 2 divided by t divided by t. And if we write this again, we're going to get 2 divided by t square. Now, yeah, same exactly same situation we're going to get, because in an angular there is any displacement is referred as a theta, which is angle, and it doesn't consider that as it is a dimensionless. So we need to multiply that, find the angle which we have already, and then use that angle to multiply this value, and we're going to get our final answer. So let's use this and let's find our value. So we're going to get alpha equals to 2 divided by 4 square. So this alpha is 0.125 second square per second square, and we need to have our angle same here, which is angle as S divided by R, and we got 16.25 radian. So what do we have to do here? We need to multiply this two value such a way we can get radian per second square. So this, our alpha is going to be 0.125 per second square times 16.25 radian. So we're going to get alpha as 2.03 radian per second square, and hence we are going to get the same answer, and we verified that. Okay, right. Now next one, number 4. Number 5 is basically a tension now, tension in the cable. Right, let's do that. Number 5. Number 5 is tension force in cable. Right, so formula again, we're going to use formula on this side, and we're going to use dimensional analysis on this side. So formula to calculate the tension, equals to F net plus basically weight. So if you look the diagram there, where is the tension happening in the cable? So tension happening in cable is here, and there is a weight of this load, right? You have FMG going down, and that is supported by this cable tension. So your net result is going to be this plus this, or this take away this, right, which is your net result, and that's what we have written our relationship here. So you can see here the net is balanced by tension plus the weight. They will cancel out each other. So I have written as tension is simply your net result plus your weight, and your net is nothing but your basically force times acceleration. Okay, so let's use that. So F equals to ma here, which is mass times basically acceleration. So we have mass as 4 times acceleration. I think we have already calculated acceleration as 0.46, 1.624 Newton. We got that. Similarly for the weight, we're gonna weight is gonna be it's gonna be mg, mass times gravity, which is gonna be 4 times 9.81. We are gonna get this as 39.24 Newton. Okay, all right, and then adding them together, we're gonna get our tension as basically 1.24, which is your mass times acceleration, plus 39.24, which is for the weight, and we got our 40.86 Newton for the tension. Right, this is from formula. And what about dimension analysis? Right, first thing we need to find the dimension for the formula, for the dimension analysis for the force. So we have the relationship. Okay, let's use that relationship. So the relationship is tension equals to force plus let's say force net and force due to weight. So we have this relationship as ma, which is mass times acceleration, plus we have this relationship as mass times gravity. So since mass is common, so we can say A plus G. All right. Now let's convert into dimension. So m is referred as m because it is a mass and it is referred as a mass. What about acceleration? Acceleration is simply, we have, if you go back to our formula of above, here we have 2L divided by t squared. That's our acceleration. So 2L divided by t squared. Okay, that is for acceleration. But what about g then? Now g is a constant, which is referred in our earth, which is 9.81, which is constant. So to get the same answer, we have to consider the same value, which is 9.81. Okay, so let's use that. Tension equals to mass, whatever value mass we have here. So it's going to be, let's write the formula first, and then we are going to multiply that with the gravity later. Okay, what we're going to get here is basically 4 times 3.25 divided by 4 square, which is going to be 1.265 Newton plus mass times gravity. For the gravity, we're going to take 9.81. Let's add that. 4 times 9.81. And we get this as same value, which is 40.89 newtons. Tension. So what I'm going to say here is G is constant. G is constant. And given by 9.81 meter per second square. All right, so once we have done